Hello and welcome back. Let us try to understand a new algorithm called K nearest neighbors. This algorithm can handle both classification and regression problems. Here I have taken a classification problem and trying to explain the algorithm, how it works. Later on we will try to understand how it works with regression problems also. So in this particular data set, there is age, salary, and whether the person defaulted a loan or not. That information is present in this particular data set. When a new person comes in, the algorithm need to predict whether the person is going to default or not. The way the K nearest neighbors algorithm works is, it looks into the closest records, the closest people to this particular person in terms of these two features, and see whether most of them are defaulting or not. If most of them are defaulting, this person may probably default the loan. If most of them are not defaulting, this person is also not going to default most probably. So that's how the algorithm works. So as a data scientist, we need to specify how many closest records or how many closest people it should look into, the algorithm should look into. So here in this example I have taken k is equal to 3. So the first step the K nearest neighbors algorithm is going to do is take this particular record 35 years and 100,000 and it's going to calculate distances between the first record and this new record, second record and the new record, third record and the new record. Like that it calculates distances. Once after calculating distances, it will take the closest 3 records as we have chosen k is equal to 3 and see whether most of them in the closest 3 are defaulting or not. So if you look at this green one, the green dot is the new record and the orange cross is a defaulted person and blue circle is not defaulted person. So if you look at the legend, blue circle is no, orange cross is yes, green is the question mark, that means the new record. So out of 3 records, 2 are not defaulted. So most probably this person, 35 years of age, 100,000 salary, is also not going to default. That's how the algorithm is going to make prediction. So we have understood how the algorithm is making prediction in a classification setup. But on a regression setup, what it will do is, it will take the closest 3 records and try to take the target variables average and make that as prediction. On a regression setup, the target variables average is the prediction. On a classification setup, the target variables flag is the prediction, right? Most of them, what is the most of the highest probability flag is the prediction of this particular record. So we understood how the algorithm is working. Let us see how it is calculating the distances. So there are 2 ways to calculate distances. One is Euclidean distance, another is Manhattan distance. If you look at these formulas, these 2 formulas, even though you pass 2 vectors, the formulas are going to output one number. We will use either of either Euclidean distance or Manhattan distance. Let us think that we are using Euclidean distance to calculate the distance between the new record and the existing records in the train set. So this P is the new record. So in our particular example, we have got only 2 values there, right? The age 35 years and the salary 100,000. For X, you can take the first record first and then substitute into this. That means 35 minus, if you look at the first record, 20 years and 10,000, right? You 35 minus 10,000 square plus 100,000 minus 10,000 square root. We are actually applying square here to avoid cancellation effect. If you subtract one from the another, if you get negative number and a positive number which are equal, if you don't square, they both are going to become 0, saying that both records are actually one on top of other, but that's not true. So we need to capture the magnitude of distance. So we are squaring it, summing it, and to nullify that squaring effect, we are applying square root. So that is the Euclidean distance formula. So similarly Manhattan also, it is taking absolute value. Whether you get negative or positive, it is going to take positive and sum it up. That way you are going to get the magnitude of the distance. Okay. So this is how it is calculating the distances. If you look at this particular example, it took the first record, the new record, took the first record and calculated the distance, right? 35 minus 20 plus 100,000 minus 10,000 square, right? 15 square plus 90,000 square root, and we are getting 90,000. So if you look at this, right, the outcome of the distance measure, the Euclidean distance measure, is mostly close to the salary than the age, because the age number is very small when compared to salary. That's where the number is close to the salary. So this is one disadvantage with k nearest neighbors. K nearest neighbors actually gives more priority to the columns which have got higher values. To avoid this, right, to make the algorithm look into each column equally important, we may have to do standardization. We'll see that in a moment. But here it is calculating the distance between the new record and the first record. It has got something, new record and second record, and new record and third record, new record and fourth record. Like that, it's going to calculate distances between this new record and all the other records, and choose the closest 3 records. As we have seen it in the diagram, it chosen these 3 records after calculating the distances. And out of these 3 records, 2 are not defaulted and 1 is defaulted. So if you look at this, this record is defaulted. These 2 records which are close to the new record are not defaulted. So the new record is also most probably not going to default. It is okay. It is safe to lend him or her the money. So that's it on how k nearest neighbors works. And in the next session, right, we'll try to understand how to make each feature, all features important for k nearest neighbors. We have seen a scenario there where the salary is a big number and age is a small number. When we are trying to calculate distances between one record and another record, the outcome, the distance outcome, is showing you a number close to the highest valued column. To avoid that, we have to do the normalization or standardization of the columns. So we'll see all those intrigue details of k nearest neighbors in next session. Thank you.